So as an astrophysicist, I often get asked, what do you actually do all day? And I respond with, well, I try to answer questions that no one knows the answer to. But that's kind of still hard to wrap your head around, so I figured the best way to get that across is to show you and bring you along with my day. So this is my office in the physics building. I love it. It has glass walls that I can write on and feel like house solving a mystery. For us, it's never aliens, like it's never lupus. The first thing I did though was check whether my code has been running okay overnight and it's not crashed. As you can tell from my happy dance, it did. This is a code that tries to find the best model of the star formation history in a galaxy given the light that we observe from it. I call it Snitch because it's seeking the best model. Anyway, my terrible puns aside, it's got lots more galaxies to run on, so time to make myself a drink. Now, you might think I'm off to make a cup of tea, but for fear of getting kicked out of Britain for saying this, I don't like tea. I don't like coffee either, so I'm having a hot squash because it's really cold out, which is not a vegetable for all you Americans watching. It's like a concentrated fruit juice that you can have either hot or cold. This is apple and blackcurrant flavored. I'm not really used to drinking hot drinks though, so sometimes it's too hot for me. Ouch. But anyway, time to actually start some work. So the first thing I do every morning is write a to-do list in my bullet journal. I love bullet journaling. It kept me organized enough to write my PhD in 2 months, which is crazy. After that though, I pick some tunes and then get to clearing my inbox and replying to some emails. I, get a mix of emails in a day, some from subscribers with questions, and then lots of science emails from collaborators sending draft journal articles through, or a new plot that they've made that people are discussing on the thread as well to work out what it means. Those are my favorite kind of emails. An email I get every day though is from what we call the archive preprint server, which is essentially an archive for all of the astronomy journal articles but allows you free access before the journals publish them. And the email basically sends me a big list of all of them that have been posted that day. So I'll scan down the list, I'll pick out ones that I think are relevant to my research or just generally interesting really, and I'll give those a quick read. Often I'll read the abstract, which is kind of like the blurb or the summary of what they found, and I'll look at the figures and the captions and maybe read the conclusions as well. I disappear here for a sec because I've gone to the printer to grab the one that I've printed out to take to Journal Club later, which is where a couple of us get together and we discuss the latest results. So I'm back and I've now started to do a little bit of research. So I wrote a journal article 2 years ago that compared this star formation history, sort of the history of star formation in a galaxy, for those that rotate and for those that don't. So like a spiral galaxy versus like a blob galaxy where the stars are on chaotic orbits. And I made a prediction at the end of that paper that said that the ones that rotate should contain more hydrogen gas than the ones that don't. Now the data I needed to do that at the time didn't exist. But now there's been this big survey to try and get the amount of hydrogen gas in a big sample of galaxies, and it's the sample that I originally drew my 200 galaxies of rotating and non-rotating from. So I grabbed that data and I got to grips with it a bit before I matched it to my old data to start with. Someone popped in at this point for a chat about plans for tonight. But then back to the data, you can see I've been making a plot of the distribution of the amount of hydrogen gas in each galaxy. So for the rotating ones and comparing it to the non-rotating ones. Unfortunately, it wasn't very conclusive because even though I started with about 200 galaxies, when I matched it to the new data set, which isn't quite complete yet at taking all the galaxies, I only ended up with 40 of them. And only 3 of those were the non-rotating ones. Now that can tell us a lot. It means that a lot of the non-rotating ones probably didn't have detections in the first place at all, so they probably don't have as much gas in them like I predicted. But 3 galaxies doesn't exactly give me good statistics, so I'll need to do a test later on that to confirm. All that data crunching though has made me hungry, so it's a good job that Thursdays at 11 is tea time in the physics department. So I have to head all the way upstairs, so I'm knackered when I get to the top, but it's a very nice view though. And you get to walk past Jocelyn Bell Burnell's office with a casual picture of her with Barack Obama outside it, just for some inspiration in your day. Anyway, here's a poster advertising the big public talk we've got tonight from Heino Falke, one of the members of the Event Horizon team who took that really famous picture of the black hole back in March. But for now, the department gathers to chat over tea and, most importantly, cookies. Then it's a mad dash over to the new physics building. There's about 3 physics buildings all within 3 minutes walk of each other, and when there's a seminar on, you have to be ready to dash between them, even in the rain like today. Today, the seminar will be given by Heino Falke. Unlike his talk this evening, which is aimed at the public, this one is for us experts to catch up on his latest work so we can ask him questions and figure out how it fits in with the science that each of us are doing. So Heino's talk was all about his efforts along with his group of postdocs and students to understand growing supermassive black holes. These are black holes that are millions to billions of times more massive than the sun, and they're found in the centers of galaxies. Now, whilst I focus on how supermassive black holes affect the galaxies they live in, Heino focuses on what's happening on the smaller scales directly around the black hole, specifically modeling the inflow of the material around the event horizon, that point of no return where you have to be traveling the speed of light to escape. And these models that Heino and his group make can then be directly compared to the image that the event horizon team are taking of, say, Messier 87, the famous one they released earlier this year, and the black hole at the center of the Milky Way, Sagittarius A star. So, of course, all the questions were then on when we could expect the Sagittarius A star image, like the one they took of M87. The answer was, don't hold your breath. They're still working on it, but at a bit of a slower, healthier pace than they did with the M87 one. After that's finished, it's time to go get lunch, which is back over towards the building I work in. Now, you would think the most likely place to find an astrophysicist in Oxford is the astrophysics building, but not at lunchtime. The most likely place then is Taylor's Deli, and it's great having such a good deli so close by to the department. It's so easy. Today, I've gone for a nice salad because after the big public talk tonight, we'll actually be taking the speaker to dinner in college, and that will be super rich food, which I'm very excited for. But until then, we have to go back to the department canteen to find, well, everybody else really, because, well, everybody needs a break in their day. Which is why in a department full of physicists, it's sometimes hard not to end up talking about physics at lunch, but most of us don't, just because we need a break from thinking about it at our desks and seminars all day too. So we try and just have a laugh. Paul on the right here has just passed his Viva. That's the PhD defense, where 2 examiners read your thesis and question you on everything you've written in it and check that you know your stuff. And then that's when you become a doctor, when you pass. So we were congratulating him on passing and asking him how it went and how it feels to be a doctor now. Anyway, can't sit around all day, so back to the office we go to do some more science. Or in my case, apparently quickly check emails and quickly check Twitter. My phone has been doing all the recording today, so I'm missing the sort of quick bits of phone procrastination in my day. Anyway, here I am reading up on some notes I made for my Night Sky News video that went up last week, because I also talk about the same thing each week on BBC Radio Oxford with Lily Mitchell. Lily is great. She lets me come on the radio for half an hour each month and talk about anything from Jupiter to cosmology. So I'm just reminding myself here of the main point before just sending off a few more quick emails and packing up to head out again. I feel like I'm going to be meeting myself coming back here, but BBC Oxford is up in the northern town, a 30-minute walk or so, so to save my poor feet and some precious research time, I usually just hop on the bus for 5 minutes up to Summertown, because the bus handily stops right outside the BBC. I wait outside in the waiting room, and then the producer of the show comes and gets me and leads me through the back and into the studio. And here's Lily. She's wonderful. I love her. She's so enthusiastic about space, so obviously we get on. And she asks all the right questions as well. You know, people at home are also thinking. So here she is getting me set up with all the microphone and the fancy headphones that make me so professional. The song ends, and then she introduces me.
Astrophysicist Dr. Becky Smith. It's lovely to have you, as we do every month. We're going to gaze skywards to begin with. Can I just say how gorgeous the moon is looking?
Yeah,
at the moment.
Every time I've been walking home, it's so full and bright, isn't it? And it's so low down as well. And then for the rest of the time, she gives me free rein to explain to people, you know, how to catch Saturn in the sky and the upcoming Geminids meteor shower. I also talked about the smallest black hole found so far that can tell us how big stars have to be when they die to make black holes. And I talk about the current crisis in cosmology, where none of the data agree on the current age of the universe, and we don't really know what to do anymore. It means there could be lots of new physics, which is super exciting. I think it's so important to talk about this sort of stuff on local radio because, for one, the research is happening so close to people every day, and also taxpayers partly fund this research as well, so we should always communicate findings back to them. But enough glamorous radio for one day. Back to the office now and back on the bus again, where I thought I could film myself reading over my notes from the seminar before lunch, but oh no, oh no, camera overboard. Quick rescue it, make sure the phone is okay. Phew, didn't crack my screen. Shocking. Really, I'm a physicist. I should have seen that one coming. Damn gravity. But off we go back towards the city centre. This is just down the main road, but it's a really pretty route in. I guess I'm starting to sound a bit like some sort of tour operator now. But anyway, we're coming back past the physics building. That weird massive tower used to be like a particle accelerator back in the 50s. But now it's the PhD student offices, which is pretty cool. I never had a desk in there, unfortunately. I'm kind of missed out a little bit. But I did get an office with a giant window, which is more than I can say for my office now, even though it's made of glass. But back at my desk, I made another hot squash and then sat down to work, or actually I probably watched the John Lewis Christmas advert first. That Dragon Edgar is adorable. I'm a veritable Tiny Tim at Christmas time. Anyway, back to that statistical test on my sample of galaxies I was working on this morning. I wasn't very hopeful that it would come out with anything significant because I have such a small number of galaxies after matching to the data that I have, and I was right. If I had 10 times the galaxies, it would have been a significant difference. So I guess it'll just be a waiting game for the data that I need to come through. I'm doing all of this analysis using Python and Jupyter notebooks though, for those who are curious. I think that's my one piece of advice to any aspiring researcher or scientist out there, is to learn to code. Because, you don't want to be doing all of this data science with huge samples in like a spreadsheet, because it's not fun. Just after 3, it was time to head back upstairs to find the seminar speaker from before. I wanted to talk to him about his work and how it specifically fits in with mine, and specifically a hypothesis that I have. So Heino looks at what happens on the small scales right down near a black hole and how the material is taken in there. I think about how the material that's taken in or even thrown back out before it even makes it past the event horizon affects the surrounding large scale of the galaxy. So for my most recent paper, I came up with a scheme to explain the findings that we had for black holes that had grown via very calm feeding compared to those that had grown through very chaotic feeding from like mergers of galaxies. And so from what we found, I wanted to run this theory by him and see what he thought. And he gave me a lot to think about, especially thinking about what assumptions had gone into our results beforehand and how that could be affecting our conclusions and our findings. Back downstairs to my desk though, I'm putting some nail oil on here because cuticle care is important, people. And I've got about 25 minutes before my next meeting, so I decided to put a tweet out about my latest video that went up last night when I was filming this. So I started clipping about 30 seconds of it to post. My colleague walks in though and asks me if I can help with a favor, and then we had a good chat about science for a couple of minutes, where we were both up to in our work, just catching each other up. I updated him on my chat with Heino, for example. Then I finished clipping my video, converted it to a format that Twitter actually likes, and then I posted the tweet. Then I wrote a note just reminding myself of what Heino and I had talked about, so that when I come back to it another day, I won't have forgotten. So I quickly checked my emails again, and then I grabbed that paper I printed out earlier today, ready to head to Journal Club with my group, which includes my PhD student, Tobias. Say hi to Tobias, everybody. And I was getting cold again. So I made myself another hot squash, this time in my favourite mug.
Oi, with the poodles already.
Then the professor in our group, Chris, joined us and we got chatting about each of the papers we brought. So I brought one on feedback from supermassive black holes. Obviously, that's my thing. Tobias brought one on how star formation in galaxies in very dense environments, so like big clusters of galaxies, is usually lower. And Chris brought one on a special type of star in the Milky Way. No one person can be an expert on everything, so this is why it's good to get people together to go over new results, because you get differing viewpoints, you get different analyses, you get different hypotheses that come out of it, and get ideas for what you might want to do next. Like, what's the next observation on a telescope that you want to make? Like, what data do you need to get? That's sort of the standard process in astronomy. You get an idea, you apply for time on a telescope, either an optical or a radio or an X-ray, whatever it might be. Hopefully you then get awarded that time and you get to go observing either in like Hawaii or La Palma or Australia or Chile or somewhere like that. Then you get to come back and analyze the data, figure out what it's telling you about the universe, and then publish a journal article on it before the whole process starts again and other people around the world are discussing your paper at a journal club somewhere. It's why no 2 days as a scientist are ever the same, but I guess this one kind of gives you a good reflection. With Journal Club finished, it was time to get changed before the public talk tonight, ready for our fancy dinner later. You have no idea how pleased with myself I am that shot worked. Is Editing Becky a real editor now? Anyway, the walk to the other physics building took me a bit longer in my heels this time, but I got myself a good spot before the lecture theatre filled up with members of the public arriving for the talk as well. Heino did such a good job explaining radio astronomy, the centre of our galaxy, observations of the stars orbiting the supermassive black hole there, and also just gravity itself as well, to communicate why things are so weird around a black hole, and maybe what would happen to anything falling in. This was all to lead up to how him and the Event Horizon Telescope team managed to make that amazing image of the supermassive black hole that's 4 billion times more massive than the Sun at the centre of the galaxy Messier 87. He explained all about how the telescopes are combined across the entire Earth to make a telescope with essentially an effective diameter of the Earth, and how the data was then combined to make the image. I got very excited at one point when he talked about plans to take this one step further and put a telescope into space or even on the moon to make the effective diameter of the telescope even bigger, like as big as space. Something we actually call space interferometry. But the snippet of information I took with me from this talk was that 4.5 billion people worldwide have seen that image of M87, which is a truly incredible achievement. With the talk and the Q&A session all done, you can see I got very excited about space interferometry in my notes. There was a drinks reception afterwards so that members of the public could interact with Heino and also members of the physics department to ask more questions about what they'd just heard. But then later it was off to dinner in college. Oxford colleges are one of the best parts about being in Oxford. It's where the undergraduates live and are taught, and it's kind of like a hall but with more of a community and sort of a familial vibe to it. For me, it's just a great place to socialise with other academics who aren't physicists and to be involved in this great community that's really steeped in history as well. Like, our college was founded by Henry VIII, so there's so much history when you walk these halls. You can see, though, it was very dark outside by this point, so here's some shots I took in the light another day, and some of you might recognise it, especially the stairs and the balcony of the hall. This is Christchurch, but it's also the first thing of Hogwarts that you see in the Philosopher's Stone.
Welcome to Hogwarts.
Like, Neville found Trevor there, and look, that's the balcony where Hermione was never better.
Never better.
Now, whilst we do usually eat in hall at the high table as a researcher at the college, tonight we're in a fancy side room for this special dinner, which is called the McKenna Room, which I love because it has this gorgeous fireplace, and it's so old school as well, with all the portraits on the wall. There's this huge one of Queen Elizabeth behind me as well, and we all got little name tags up. The college chefs are so good to us. The food really is incredible and they do such a good job, and I wish I had that level of skill. What's nice is that these lectures and dinners are a twice yearly thing here, and there's an impressive list of people that have given these lectures in the past, including 2 Nobel Prize winners and some names you might recognise from me covering their work on this channel before as well. I kind of hope to one day see my name on a list of lecturers like this too. Now, I didn't film anything at dinner because, well, that would be rude, but trust me when I say the food was amazing. But then it was time for my Cinderella dash to catch my train home after a very, very long but productive and enjoyable day. It might not have looked much to some, but this is truly my dream job, and I get to do it all again tomorrow.